In this video, you're going to try it on your own. Now, I know the last video cut off a little bit, so I want to remind you, whenever you do a combustion reaction, make sure you always balance out and check your balancing. That's going to be true for all of these. I have 4 examples on the screen. Here's what I want you to do. I want you to pause the video, write them down, and then I want you to come back and meet up with me, and let's see if we can get the answers to these. Figure out what kind of reaction, and then you can figure out what it makes, and see if you can balance the whole thing. Pause the video, we'll come back in a second. Alright, let's see if we got the answers that we needed. First thing you had to figure out was this is a single and this is a single. Remember, this is one of those 7. So it's a single replacement, so all I'm going to do is put them together. Now, if I write a formula, I got to check my charges, so let's do that. Li is right there, it's +1, right off my chart. F is right there, is -1. +1, -1, do they equal 0? Yes, so I don't have to do anything extra. Balancing the whole thing, 1 lithium, 2 fluorine. I need a 2 here to make it work. So that means 2 fluorines by the distributive property. 2 lithiums means I need a 2 there. And I'm done. That one is a synthesis reaction. In the second one, you'll notice I pick lithium again. I want to make sure you understood. Just because it's the same as this doesn't mean it's the same reaction. This is a single with a group. This is boy, girl when you check the charts. So all you got to do is figure out that that is a boy. And so you switch partners. So that boy is going to be with that girl, and Ca is all alone. Now you got to check your charges again. Li is +1, O is -2. +1, -2. That means I need that little 2. Just like H2O, I have to have that little number. If I don't have that little number, it's wrong. So there's correct formula, and that's correct formula. Correct, 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 correct. So all I need to do is check what I've got. 2 lithiums means I need a 2 there. 1 Ca, 1 Ca, 1 O, 1 O. That's done. I'm going to show you a variation of this just to make sure that you're never tricked. What happens if you had something like P is reacting with that? Well, if you look at it on the chart, phosphorus is -1, -2. It's right there. It's -3. Ooh, that's a negative. What would you do in that case? Now, I didn't ask you to do this one, but let's see what would happen. Well, that's a boy. That's acting like a girl. So that means that Ca is going to be with P. There's boy, girl. And then oxygen would be all alone. So these two would switch places with one another. Oh, so that one's acting like a girl. Okay, so plus minus. So they switch with each other. Remember, P and O don't go together because opposites attract. Those aren't opposites. So I have to check my charges. Ca is right here. That's +2. P is a -3. +2, -3. That means a 3 and a 2 when I switch them. You don't remember how to do that, make sure you go back to writing compounds. Oxygen's one of the 7. Ooh, got to remember a lot. It's one of those 7 when he's by himself, so that has a little 2, and then you could balance the whole thing and you're done. With the third one that you did a while ago, boy, girl, when you go to work this one, you get plus, minus, plus, minus. Now you'll notice how I'm writing pluses and minus. Great idea if you do that on your own. Sr is going to be with Cl, and K is going to be with P. Question, do I bring all these numbers? No. That's the numbers when they were partners. They're not partners anymore. So I have to check my charges. Sr is right there, +2. Chlorine is -1. You should have already done all this. I'm showing you. This should be a 2 right there by switching. So that's correct. K is a +1. And P is -3. So I need that number. Oh, so I have different numbers with different things. Correct, 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 correct. And you should know how to balance. So you would go through and balance that and should have it all. In the last one, it is a combustion reaction. I automatically see it when it's a carbon-hydrogen reacting with oxygen. So I know it's going to make this plus this every time. Every time. That's not going to change. So I'm burning, I make carbon dioxide and water. All I got to do is balance. The hard part about these is not knowing what it makes. It's sometimes the numbers get really big. 3 carbons, so I need a 3 there. 4 hydrogens, 4 times 2 is 8. Here's where this one's hard. I can't check these I can't change these numbers or mess everything up. But when I put that 3 there, that made 6 oxygens right there, distributive property, and 4 more. Well, that's a plus sign. 6 plus 4 is 10. If I put a 5 there, 5 times 2 is 10. That's how you do the types of reactions. What you've done is what is called predicting the products. Just by looking at the very beginning, you can tell what kind of reaction it is, and if you know the kind of reactions, you put them together or switch your partners or switch both partners, or you know and balance. All 5 types of reactions can easily be done by checking charges every time and being careful with your balancing. Quick hint, if you didn't get this 3 and 2, you'll mess up all the balancing. If you didn't get that 2 and that 3 in the right places, you'll mess up all the balancing. So the numbers are very important. How do I know them? Well, thank goodness we have a periodic table, and there are trends that we know. +1, +2. Aluminum is +3, just a reminder. All of these are 0, -1, -2, -3. So they work like this, and you can tell their charges just by looking on the chart. That makes your life so much easier. All right, we'll see you in the next video.